Hello there guys, welcome back to another inexorable video. In this video we're looking at how we're going to go about differentiating tan x. Okay, so let's just dive straight into it. We're going to use the quotient rule for this one, link in the description to the quotient rule video if you want to check that out. We're going to use the quotient rule. How on earth do we use the quotient rule to differentiate tan x though? Tan x, that's not a quotient, that's not a fraction, that's just one thing. But of course, if y is tan x, then we know that tan x is just sine x divided by cos x. And that's how we're going to go using the quotient rule here. So if basically tan x is sine x over cos x, then we can just differentiate sine x over cos x, and that is the derivative of tan because they're the same thing. Lovely. So if we just go about differentiating that. So using the quotient rule, we can let u be equal to sine x. I'm going to use this u and v notation here, and we're going to let v be cos x. You might use g of x and h of x, but it's the same idea. Okay, if u is sine x, then du dx is the derivative of sine x, which is cos x. And if v is cos x, then the derivative of that looks like a u. My v, that's a v. Then the derivative of cos x, we already know, that's actually just going to be negative sine x. Lovely. So these are all of our derivatives. And now what we do is just plug into the quotient rule formula. So the quotient rule says that if y is u over v, then dy dx is v times du dx minus u times dv dx, all divided by v squared. This is just the quotient rule formula. So we can just substitute into the quotient rule formula. Okay, so that means that dy dx, in this case, this is going to be the derivative of tan x, is just exactly this. So v is cos x, so there's our cos x going in there. Multiplied by du dx, that's also cos x, so it's going to be cos x times cos x, minus u, which is sine x, multiplied by dv dx, that's minus sine x. So they're going to multiply together there. And it's all being divided by v squared, which is just cos squared x. Okay, lovely. Okay, there we go. Almost there already. Now, here's the thing. Cos x times cos x is cos squared x. And sine x times negative sine x is negative sine squared x. But there's also another minus sign right there in the middle of them, and because there's two negative signs, they're actually going to make a positive, and it's going to become plus sine squared x. And this is going to be really helpful to simplify. You may know this, but cos squared plus sine squared, I'll actually write this down as well. We already know this is just a fact, this is a formula, this is the Pythagorean trig identity. It says that cos squared of any angle plus sine squared of the same angle is always 1 in every single case. It's always 1, which means we can replace cos squared plus sine squared with just the number 1. And that's going to be really nice to simplify. So we then end up with the dy dx there is just cos squared plus sine squared, the number 1 over cos squared x. And 1 over cos squared is actually just sec squared x. So the answer to that is that the derivative here of tan x is sec squared x, which of course likewise it means that the integral of sec squared x is tan x plus c. But of course, if you haven't done any integration yet, don't worry about that. But they go both ways. So this is not only useful for differentiating tan x, but also for integrating sec squared. It's very useful. Cool. Thank you guys so much for watching. Highly appreciate it. And I'll see you in the next video. Cheers.